Hello. Today we're going to analyze the moments on a beam. So in here we have an example of a beam sitting on two supports, and this could be a beam in a truss bridge. Um, this could be a balance beam for a gymnast. But in either case, you don't want this beam to move. You want it to remain static. All right, so a few notes about this. It is supported at both ends, but this support is a fixed point. The point A cannot move. It can't move up or down or left or right. However, point C has a roller underneath it, and the roller allows the beam to move left or right. It can't move up or down because the roller is in the way. All right, so that's an important point, and we'll visit that later. Okay, so in this situation, we have a force down, some weight of some object, for instance, and it's 2,000 pounds, but it's not right at the center. If this weight was in the center, we'd expect the forces up on both sides to be 1,000 pounds each to support the 2,000 pounds down, and it would be balanced. Again, 1,000 on each side. But we don't know that, what the forces are in this case, because this force down is not right in the middle. So then the forces will not be equally distributed. All right, since we don't want this object to rotate this way, counterclockwise, or this way, clockwise, the sum of the moments, we're using the Greek symbol sigma, m for moments, around a certain point should add up to 0. Again, this means we don't want this beam to rotate. So we're going to, again, do this around a certain point. And in this case, I'm going to choose point A. So we're going to sum the moments around point A. And we're going to add them up, and they should add them up, and we should expect them to be equal to 0. Okay, moment is equal to force times distance. So if we start here, there's a moment due to this force, and it's causing the beam to rotate clockwise. So that's a negative moment. The force down is the force causing this moment, and the distance from point A is 12 feet. I'll call it distance AB. Okay, so that's a negative moment. However, the force from C, we'll call it a reactionary force at point C, in the y direction, adding up. This force is pushing up. That's going to cause a counterclockwise rotation, or a positive moment. And that will be the reactionary force at C times the distance from A. Again, we're doing this moment analysis around point A. So it will be the total distance from A to C of the beam. And again, those should add up to 0. Well, we know the force down is 2,000 pounds. We know the distance from A to B is 12 feet. We don't know the reactionary force at point C in the y direction. That's what we're solving for. But we do know the distance from A to C, and that's 18 feet. And again, those should add up to 0. Well, this is an equation we can solve. We can get this on the other side of the equation and get rid of that, and we'll have RC by itself. All right, so let's analyze this. 2,000 times 12 is 24,000 pound-feet. Okay, let's get rid of this and put it on the other side by adding this to both sides. That gets rid of that. Now we have our C in the y direction times the 18 feet. Okay, now we need to get rid of the 18 feet, so we have the reactionary force by itself. So we'll divide both sides by the 18 feet. Feet cancels on this side, this whole side cancels, and we're left with the reactionary force at point C is equal to 1,333 pounds. This divided by 18. All right, you'll notice that is not half of 2,000. Now, because again we don't want this beam to fall, the sum of the forces in the y direction should also be equal to 0. That means the forces up are equal to the forces down. Well, what are the forces up? They're going to be positive. The reactionary force at A in the y direction, plus the reactionary force at C in the y direction, these two forces, these two forces should cancel with this force. They should all add up to 0. We don't know the reactionary force at A in the y direction, but we do know the reactionary force at C in the y direction. We do know the force down, is a negative 2,000 pounds. So again, if you solve this equation for one unknown, we get and a quicker way of saying this is just that the reactionary force in the y at points A and point C have to add up to the weight down. Thank you for listening.